Section 3.4.29, the accompanying data represent the pulse rates beats per minute of 9 students. Treat the 9 students as a population. We're going to compute the z-scores for all the students, and then we want to compute the mean and standard deviation of these z-scores. Okay, now the first thing we need to do is we want to compute the population mean of the data that we have. So we have the pulse, we have 75 to 73. So if we add those all up and the amount that we have, divide that by 9, that gives us the population of 72.2. Then we want to be able to compute the population variance. Well, the variance is taking the data value of that so 75, and you're going to subtract the population mean and square it, plus, again, the next data value, 62 minus 72.2, and square that, and so on. So we keep taking those data values, subtracting the population mean and squaring it. We're adding them all up to divide it by 9 to get the variance of 55.73. The next step is to compute the population standard deviation. So in order to do that, we need to take the square root of the variance. So the square root of the variance is the square root of 55.73, and rounding it to 1 decimal place, we're going to get 7.5 for the standard deviation. Okay, so now that we've figured out the population mean, the variance, and the population standard deviation. Okay, now I do want to point out that if you decide to use StatCrunch, you need to be careful. I'm showing this by hand because you still want to make sure you know how to do this by hand. Eventually, as we move along in the course, you can use your StatCrunch. But let's take a look here. If I wanted to do this by hand, I would go to Summary Stats and select Columns, and then go to Pulse. Now I'm going to select Mean, right, because I want the mean, but the standard deviation and the variance is not adjusted, so you're not going to want to choose those to get these particular values. If you do this by hand, these are the numbers that you're going to get. So you'd want to come down here to get the unadjusted variance and the unadjusted standard deviation. And so here, if we take a look at this data and copy that, then it's going to verify what we just solved for. You can see that we have the mean at 72.2, the variance at 55.73, and the standard deviation at 7.5. Okay. Now, we need this information to be able to find the z-scores of each particular data value above. So, if we compute the population standard deviation, the first one, you can see that z is going to represent our first value, which was the x data value from above is 75. Okay, so I'm going to pull that data down here. You can see what I'm referring to. So the first data value that we're using is 75. That's the pulse rate. So we're going to use our z-score to find out what that z-score would be for that. So it's going to be 75, which is the data value. We know that our population mean is 72.2 from up here, and we know that our standard deviation is 7.5. So we're using that information to find the z-score. So the z-score for 75 is 0.37. The next one is 62. So then we're going to use x to be 62, and then we're plugging that into our z-score formula. So z is going to equal 62 minus the population mean, divided by the population standard deviation to get a z-score of negative 1.36. Our next value, our data value, is x is equal to 60. Again, we plug it into our z-score formula to get negative 1.63. Next one, we get x, which is equal to 82. X is equal to 70. X is equal to 80 here. X is equal to 80 here. X is equal to 68, and then x is equal to 73. So it's an important exercise because you want to get comfortable with the z-score formula. You'll be seeing that quite a bit as we move along. So this is really a great exercise to get comfortable with that formula. Now, here is our table now of the z-scores. So from student 1 all the way to student 9, there are our z-scores. And so then back at the beginning of the question, they want us to be able to compute the mean of these z-scores. So if we want to compute the mean of these z-scores, we can plug in 0.37, negative 1.36, and we're going to add them all up and divide it by 9, and it gives us approximately 0.0 for the mean of the z-scores. And then when we compute the population variance for the z-scores, we're going to do the same thing that we did back in step number 2. Only we're going to be using now the z-scores as our value, and then subtracting the mean, which is 0.0. So therefore, we're going to square those values, add them all up, and then divide by 9, and we get a variance of 0.99. And then we're going to compute the standard deviation of these z-scores. So by computing the standard deviation, we take the square root of the variance to get 1.0. So therefore, this confirms that the z-score has, by definition, a mean of 0 and a standard deviation of 1. Now, again, we're doing this by hand. Now, if we wanted to then create our own table, we can go back to StatCrunch, okay, and we can put in the column up here. We can rename it and call it z-scores. So we know the z-scores for 75 is 0.37. The z-score for 62 is negative 1.36. The next one is negative 1.63. The next one is 1.31. And then negative 0.29, 1.04, 1.04, negative 0.56, and then 0.11. And then we can go back and then find the summary stats like we did before, and then select the columns. But now we're going to select the z-scores because that's the column we just selected. We're going to pick our mean, and then we're going to scroll down to the unadjusted variance and unadjusted standard deviation. I don't think we selected mean, so let me go back. So summary stats, columns, z-score, mean, and then the unadjusted variance and unadjusted standard deviation. So we should get 3 of them. So here we can check our results that we've done by hand. And you can see here that our mean is 0.00. Our variance is 0.99. And if we round this to 1 decimal place, the standard deviation is 1.0.